Hello. Today we're going to talk about roots of real numbers. So in mathematics, it's really important. If you're going to have a forwards and add, you have to have a backwards or subtract. If you're going to multiply, you need to be able to divide and kind of go backwards. Now we have powers, which means if I have a 5 squared, I'm going to go 5 times 5, so I have 2 of them, and that will equal 25. I need a way of being able to go backwards. And so roots is that way of going backwards through powers. So if I had the square root of 25, then what times itself makes 25? We know that is 5. So then if I have a 5 cubed, that being a 5 times 5 times 5, we know that is 125. Then to go backwards of a cube root, we're still going to use the same sign, but we're going to put a little 3 up here, and that is called the index. The index means what 3 things multiplied together equals 125. And so we can say, well, we know that 5 times itself 3 times makes 125, so the cube root of 125 must be 5. Likewise, if I have 5 to the 4th power, 5 times 5 times 5 times 5 equals 625. Woo, that's way up there. Anyways, the 4th root of 625 is back to 5 again. So again, it's just going backwards. All these roots. So the symbol, or this root sign right up here, indicates the nth root. And the nth root is kind of showing that n is our index. Our index is this n right here. Now, the root sign we commonly call, the root sign is really called the radical sign. And the number or the value that's underneath here is the radicand. Just a little vocab for you. Now, something that's interesting about this is if I look at the square root of 16, and I know it equals 4, because 4 times 4 equals 16, this is not the only root that's out there. Because I know not only does 4 times 4 make 16, but negative 4 times negative 4 also equals a positive 16. So there's 2 roots. So now we're going to get into which root are they looking for. So there's a word, there's a phrase, it's called the principal square root. And that's going to be that positive square root. It's the one that comes to mind first. So now, if I want the negative root, they're going to do something a little different. They're going to put a negative sign out front here. And so if there's a minus sign out front of that square root, that's when they're going to want the negative 4. So the negative square root of 16 is a negative 4. Notice that there's no negative inside that square root, because a negative times a negative does make a positive. So how could I take the square root of a negative 16 on the inside? Well, what times itself makes negative? Well, if it's timesing by itself, or any even number of terms, it'll always be back to positive. So there's no real solutions for the square root of a negative value. However, you can take the negative of a cubic, because a negative 5 times a negative 5 times a negative 5 does make negative 125. So if your index is odd, you can take the root of a negative value. If your index is 2 or 4 or any even number, you cannot. Now, we assume that there's no 2 up here. We assume this as a 2. What times itself 2 times? If it's anything other than 2, then we have to write that number. So what's the 4th root of 81? Notice they want the negative sign outside. That means they're looking for the negative 3, because negative 3 times negative 3 times negative 3 times negative 3 makes 81, and it's positive. Okay, so, I missed one more thing, and that is this plus and minus. If you ever see this plus and minus, now they want both roots. They want both square roots of 16. So that's how you're going to know. If they just see a positive square root, they want the positive. If there's a minus out front of it, they want the negative root. And if there's a both plus and minus, they want both roots. All right, so let's take a look at these. So if I had something crazy like the 8th root, if I had the 8th root of x to the 8, that means what times itself 8 times makes x to the 8? Well, another way of saying this is the 8th root of 1, 2, 3, 4, 5, 6, 7, 8 x's, oh my gosh, all multiplied together. What times itself 8 times makes that? Well, that was just an x. Okay, so this tells you the grouping. How many of those do I need in there? Now, what's interesting in this next one, the square root of x to the 4, is we assume that this is a 2. So what times itself makes x to the 4? Well, x to the 4, I could break it up as x times x times x times x. If I'm making two groups of the same thing multiplied to itself, notice it's just x squared. So this is really x squared, because I have two of them in each group. So I could write this as an x squared times x, x squared. Or that is the square root of x to the 4. Okay? So it equals x squared, because x squared times x squared makes x to the 4, but times itself. Okay, so do you notice there's a dividing thing that could happen here? Do you notice that if I had x to the 4, do you notice that I could have just divided this thing by 2, and then that would have equaled x squared? So in a way, when I have these groups of these, I can just divide them. So this is like saying I have 8 x's and I've divided by 8. Okay. Well, then what do I do here with the 8th root of x to the 4? You can call this x to the 4 divided by 8. Now, you know that this is not really simplifiable, but I could simplify it and just call this x to the, treat it like a fraction instead of dividing by 8. I could just call this 1/2. Well, where did that half come from? Where did the 8? The 8 was out front. The 8 was your index, and that's on your bottom. So what do you think looking at this bottom, this 2 is going to mean? It means square root of x to the 1. And you can go back and forth from fractions, which we're going to talk more in our next lesson. But just to lay down some of the where we're going, it's a little bit helpful. Also, what if there's fractions in it? Well, guess what? This is really the cube root of 1 over the cube root of 125. So what times itself, that's 3 times, makes 1? Well, 1 times 1 times 1, that would be a 1. What times itself makes 125? Well, earlier we talked about this. That is a 5. And so you can break these up over multiply and divides, and fractions are nothing more than divides. We'll talk about this a little bit more in the next section also. So what else are you going to get in this section? You're going to get asked to simplify things. So what if I have something that big? How do I simplify it? There are 2 options. So option 1, number 1, you can take and split this thing into different groups. What is the 5th root of 32? Times, what is the 5th root of x to the 15? Times, what is the 5th root of y to the 20? Okay, looking good. I'm going to treat them as separate so I can only think about one. Well, 32 really is, so we have the 5th root of, I'm going to call this 2 times 2 times 2. That's 8 times 2 is 16 times 2 is 32. Okay, how many of them there? That's really 2 to the 5th power, isn't it? So if I'm saying I need the 5th root of 2 to the 5th power, then this just equals a plain old 2. Okay, or you can go 5 divided by 5 is 2 to the 1 power. That also works. Okay, so if I wanted to do that with this x to the 5, I could take this 5 and call this x to the 15 over 5. What is 15 divided by 5? That's just x to the third power. And likewise, I can take this 5 and divide it by that 20. So I get y to the 20, but then divide that 20 into 5. How many groups of 5 could I make if I had 20 y's? It's a whole heck of a lot of them, and I really don't want to write them all out. So 20 divided by 5 is just y to the 4. Now you can put them all back together, and your final answer is going to be a 2x cubed y to the 4. So you can split these things apart as long as there's no addition or subtraction. That's the one caveat you got to watch out for. As long as there's no addition or subtracting. When these things are all multiplied or divided together, you are free to break these roots apart into separate roots and just handle them separately. All right. Hope this helps. Good luck. Have a great day.